video, we'll be seeing the basic mathematical concept behind the formation of pin codes. So see this question, for instance: how many 5-digit codes can be formed from the digits 2, 3, 4, 5, 6, 7, 8 without repetitions, such that the code is even? So now you want to hack a pin code, and the information you have is that the code is a 5-digit code. The code is even, that is, the last digit is an even number, and then there is no repeated number in that code. All the 5 digits are distinct, none of them is repeated. Then mathematics, particularly the concept of permutation, can help us know the amount of effort you put in to getting that pin code, to hacking it. When I say effort, I mean the number of trials you have to run to get the exact 5-digit code. Of course, you might be lucky, your first trial might even give you the code, but we're saying in the worst case, the maximum number of trials you would have to go through before you eventually get that code. This concept of permutation can help us with that. So the analysis of the question now is that we have this available set of numbers for the pin code. The pin code is generated from this set: 2, 3, 4, 5, 6, 7, 8. These are the numbers that are contained in the code, but then it is a 5-digit code, right? And another information is that the code is even, that is, the code must end with either 2, 4, 6, or 8, because those are the even numbers in this set that were given. In our set, we have a total number of 7 digits, and for the last position, the last number in our code, we already know that it can be any of these 4 numbers: 2, 4, 6, 8. Now, a 5-digit code is even if the last digit is even. We've said that. And so if we take out the last digit from our guess, we already know our last digit is any of those 4 digits, right? 2, 4, 6, 8. If we take the last digit off, let's now move to the first digit. For our first digit, we'll be having 6 numbers left. Remember, the total number of digits we can pick from are these 7 digits. Our last digit is taking one number at a time, and so at every instance that our last digit has taken a number, we are left with 6 numbers to fill up the first position, right? And then the second position, at every instant that our first position has taken one number, the second position is left with 5 digits, because our first position has taken a number and our last position also has taken a number. And the third position too, similarly, at every instance like that, the first position has taken a number and the second position has taken a number. So the third position will be left with 7 minus 3, because we know already our last position is constant. So 3 positions are taken already: the first, the second, and the last. So the third position is left with 4 positions and 4 choices from the 7 total choices to pick. And then finally, the fourth position, we have 3 choices left because the first position has taken a number to leave 6 numbers. The second position has taken a number to leave 5 numbers. The third position has taken a number to leave 4 numbers to shuffle. And remember, the last position, the 5th position, is fixed already. And then so I left with 7 minus 4. The first, second, third, and last, those 4 positions are taken. So for the 4th position, 7 minus 4, I left with 3 numbers to shuffle on. And so we multiply each of those instances. The first position has 6 numbers to choose from. The second position has 5 numbers to choose from. The third position has 4 numbers to choose from. The 4th position has 3 numbers to choose from. And the last position has 4 numbers to choose from, right? Because there is no repetition. That's why whenever we pick one position is gone, we subtract it from the total number of choices that we can pick a digit from to shuffle. And so when we do this multiplication, we have 1440 ways of running that shuffle. In essence, if you have all this information about a particular pin code, then you know that at most you have to put in 1440 trials before you can hack the code. So because the number of trials is very high, you might need to get more information, like probably the first digit of the code. That narrows down the number of shuffles again. The more the information you have, the less the effort. Now, this second example is similar. It's saying the last digit in this case is odd. So our last digit will just take 3 of the 7 choices. 3, 5, 7. Those are the odd numbers. And the same procedure ensues. So you can just pause and go through. I want to move to a situation or a case that is quite different. Yeah, we have a quite different case here. How many 5-digit codes can be formed from the digits 2, 3, 4, 5, 6, 7, 8 without repetitions, such that the code is greater than 50,000? That is 50000. This is the set we're choosing from, these 7 digits, right? We're told that the code is greater than 50000, right? And so the first position is known already. To take either of these numbers, 5, 6, 7, or 8, because those are the only possible numbers that can make the code eventually greater than 50,000, right? Then, since repetition is not allowed, the moment the first number is gone, we're left with 6 numbers to choose from. That is, in this set now, if I pick 5 to be my first digit, I'm left with 2, 3, 4, 6, 7, 8 to choose for the second position. That's why I have 6 numbers left, right? And it keeps descending like that because the second position will also pick a number, and we'll be left with 5 numbers to shuffle from. for the third position. For the fourth position, because the third position has taken a number, we'll be left with 4 numbers to shuffle on, and the fifth position likewise we'll be left with 3 numbers to shuffle on. So finally we multiply each of the cases. The first digit has 4 choices, 5, 6, 7, or 8. Then the second position, 6 choices. Third position, 5 choices. Fourth position, 4 choices. Last position, 3 choices to pick from. We do this sum, and we'll discover that we can get that code at most by 1440 trials. Now I want to see a case where repetition is involved. Of course, this particular example is just similar to the last one. The only difference here is that we're saying the code is less than 40,000 in this case. That means our first digit must be 2 or 3. The moment our first digit is 4, the code will already be greater than 40,000. So our first digit can only take 2 choices, right? And the other positions will take one choice each and keep removing from the total, just like we've seen in the previous examples. And we'll have a solution for this as well. 720 ways of doing that. Now this is a case where repetition is involved. How many 5-digit codes can be formed from the digits 2, 3, 4, 5, 6, 7, 8 with repetitions such that the code is even, right? If the code is even, we've seen earlier that the code must end with 2, 4, 6, 8. Now, because repetition is allowed, a digit can be used more than once. So the number of choices for the last digit, that one is fixed, is 4, right? Now the number of choices for the first digit will remain 7, because we can repeat even the number that was chosen at the last digit, so we're not subtracting anything this time around. And for the second position, the second digit, we have 7 choices as well. Third position, 7 choices, because whatever number has been chosen at any position can still be repeated, right? So the solution at the end of the day is 9604 number of total shuffles that can give us the desired code at most. And then this is a similar one where the code is odd, right? The first position is 3. Every other position must have 7 choices. The solution, 7,203 possible shuffles. And finally, let me take this one where the code is greater than 5,000 and repetition is allowed. We have a set of 7 numbers. If the code must be greater than 5,000, then the first digit can take 5, 6, 7, or 8. That is 4 choices are available for the first digit. Every other digit has 7 choices that we can pick from, because we can repeat any of the positions, including the first position. If we chose 5, for instance, for our first position, the second digit can also be 5. It can be any of 2, 3, 4, 5, 6, 7, 8. right? Because repetition is allowed, every of or the other positions can take 7 choices, and so our solution is 9604 ways. I'll stop there. The other last example is just similar. Thank you for watching.